And so that brings us on to the combination of Fleet and Homebrew. And going back to OS Query, which we mentioned a couple of times, there's a really cool synergy here. Brock, to get that started, do you want to tell us about what OS Query is and how it works?
Sure. So, as I mentioned, OS Query was something that was developed as an open source project, but inside Facebook. I think it was in 2014. I was working at Jamf at the time, and I remember very, very clearly when that was happening, because it was very clear that Facebook was going to be building their own solution for managing, and OS Query was at the heart of that. Since that and I will openly admit this. There will be two admissions that I'll have to make on this call, especially because Rob is here. I was very skeptical of OS Query when I heard what it was going to be doing. And the reason I was skeptical of it is because I didn't believe that it would be possible for an open source project to be able to maintain the knowledge level that was needed to properly maintain the life cycle of how they were collecting the information. My thinking was Jamf is pretty good at understanding how Apple stuff works. And certainly Apple is pretty good at understanding how Apple stuff works. I don't know how this third party or open source project is going to be able to keep up with all of that. But the fact is, I was wrong about that. Not only have they kept up with it, but it works on all platforms. New tables are being created all the time. Tables are being created by the community. So it's a very powerful tool. And basically, it's a simple concept. It's that the data on a device can be expressed as a SQLite table. And there's an agent that lives on device that does that. There has to be a table written to run by the agent in order to collect the information from the device. So, for example, OS Query recently added a system profiler table. Many of you may be familiar with the system profiler binary. You can type in system profiler and you get lots and lots of information about your computer. That table never existed before. It was just recently added. Why is it helpful? Well, it's just another way to get information easily from the computer. And there's a table now that lives in the OS Query schema that allows that data to be parsed so that it can be used in Fleet. How can it be used? Well, queries are used in a number of different ways. They can be used to just collect information and have that sent to a logging destination. They can be used as one-offs to find an attribute of a particular system. They can be used as what Fleet calls a policy. And a policy in Fleet is basically a SQL query that's written to generate a Boolean result. And if that policy fails, you can then trigger an automation action. So you can trigger a script to execute. You can trigger a software installation. You can fire off a webhook to a ticketing system or to any middleware that would be capable of listening to that webhook and then performing another action in another system. That could be an API call back to Fleet. That could be an API call to send a notification to a Slack channel. Very, very powerful integration capabilities are available from these simple SQL queries that you can create in Fleet with the OS Query framework. And the other thing I guess I'll say about that is that one nice thing, one advantage of Fleet having this capability across all the platforms is that it means you really only need to learn one method to collect information from all of your devices, regardless of the platform. Now, you still need to understand the basics of Windows versus Mac. There are Windows specific tables and Mac specific tables, for example. But the power of OS Query is that it lives on all these different types of devices on all these different platforms. And once you understand how simple it can be to create SQL queries to get information from them, and that you can trigger action based on those results just by checking the device state, you can see that it becomes a very powerful system. Real quick, there is a homebrew packages table in the OS Query schema. I don't remember where that table came from, if that's an OS Query native table or if it was something that was added. I apologize for not remembering, but usually it's documented where the tables come from. Many of the tables have come from the community, and the Mac admins OS Query project is a great source of many tables that we actually use in Fleet. So big shout out to those guys for creating extremely useful tables in OS Query for Macs. One place I've used this homebrew packages table is when the XZ vulnerability happened last year. We were able to start discovering computers that had XZ installed immediately because we had the homebrew packages table available. So just gives you an example of the kind of power that this has. And I guess I'll say one other thing that's a little bit pitchy, but Fleet is not only a device management platform, it's also a vulnerability detection platform, and it also can be used as a pure security platform. So the ability to express all this data and collect it via OS query is Fleet's secret sauce.
Yeah, and that's one of the things that I've got a brief note on this slide that I think it's a really interesting complement for the Workbrew console for automation observability. But I think what's like there's some really fun, I think, automated API through to OS query potentials here. The Workbrew console shows you, hey, I've got a suite of Macs who have this potentially vulnerable package or this package that's out of date. You can, drop that into OS query, check what's going on with them. I think there's some really interesting synergies there that we've not seen. Well, I haven't seen anyway. Some of the other folks in Workbrew may have not seen explored, I think, to their full potential. And so I think there's some great possibilities there.